So we have 2 times e to the x times e to the 2y. And then we can rewrite all that as a product. And we have our simplified equation. And then we can go ahead and collect our terms by moving the y's to one side and the x to the other side, depending on the operation that happened. So I divide by e to the 2y on both sides. And so all of our y's are on one side. And we have all the x's on one side. And now we can integrate simultaneously both sides. And so we have the integral of 1 over e to the 2y dy equals to the integral of 2 times e to the x dx. And we know that's 2 e to the x. And so for this part, with the y, we can do u substitution. And so I set u equal to e to the 2y, and we find the derivative of that, which is 2e to the 2y. And we can go ahead and say that du is equal to 2e to the 2y dy, and we solve for dy since we want to substitute this for u and substitute this so we can have all terms of u, yada yada. And it looks a bit suspicious when we do the u substitution because we have a y here. But if we go ahead and continue and replace everything, we see that when the dy gets replaced, we have this function. And we can notice that this e to the 2y is also our u. So now we have the integral of 1 over u times 1 times 1 over 2 e to the 2y du. And so now we can rewrite that as the integral of 1 over u times 1 over 2 u du. And we can move this 1/2 on the outside of the integral since it's a constant. And so now we have 1 over u squared du. And we have our integrals and constants all in the right place. We can rewrite this as u to the -1 to the -2. And then we can go ahead and integrate. And so we're left with this. We can go ahead and unsubstitute u as e to the 2y. And then we can go ahead and simplify again. And so we're left with this, and we pick up a constant from the integration. And we say that this is equal to e to the 2x from above here, right? So the y's and the x's. And so we can simplify for y since that's what we're looking for. And we can go ahead and do that by multiplying by e to the 2y on both sides. Here it's in blue. And sometimes I'll do this, I'll color code it if it's, understood. And so now we're just left with -1/2 equals to this. And then we're going to go ahead and divide both sides by this. So we can go ahead and get for the y. And then we're going to be left with e to the 2y, which equals this. And we can go ahead and apply our initial condition where y of 0 equals to 1, where the output is y. And here's our x, which is 0. And we can go ahead and place that into our equation here. And then we'll be left with this e squared equals all this stuff here. And now we're going to solve for our constant. And solving for our constant, we multiply both sides of the equation by this. And so here we go. And we can go ahead and expand it out and simplify our equation. And you can see everything that's going on here. So I won't tell the minute details, but this is in general what's happening. And so we find our constant, and given our general equation, which is above in terms of y, and which is explained by x, we can plug in our constant, which we just found here. And thus our differential equation can be explained by this in the green, given our initial condition. And if you really want to just solve for y, here would be your answer after doing, the natural logarithm of e to the 2y, which will just leave you with 2y. And all of that is in the parentheses, which is this. And this would be your final answer. Thanks.
Wow. Okay, thank you. If anyone has any question, just jump in to ask.
Yes, no problem. If anyone has any questions. Sorry I didn't go too in detail, but it's just like a bunch of steps, a lot of steps.
It's great. Yes, it's great. Let's see. Okay, so Liz, David, Moses. Oh, hold on. Su Xian. Okay, let me make you presenters as well. David. All right, Liz. Okay. All right, Gregor, who's next?
My turn.
Yeah.
Yeah.
Okay.
Hi.
Go ahead.
Can you guys see my screen?
Not yet.
How about now? Oh yeah.
Yes. Yes.
Okay. So I'm presenting question 5. So first of all, I did cross multiplication, and then I got 3y squared dy equals 2x plus 3x squared dx. Then I took the integral of both sides, and then left hand side became y cubed plus c, and then the right hand side became x squared plus x cubed plus c. And then I combined the constants to the right side, and then to solve for y, I picked the cube root of the right side, and then since we were given y of 1 equals 2, I plug it in the values for x and y, and then I solve for c, which became 6, c equals 6, and then I put it in, and then the final result was y equals cube root of x squared plus x cubed plus 6.
I'm lost.
I'm
lost. Where's your final answer? Where?
So it's am I able to write on the screen? Yeah. So this was my final answer.
Okay. Yeah, I see. Okay. Right. I was looking at the wrong spot.
I'm sorry. I couldn't fit it in the space. Sorry.
Okay. Just one thing. Just when you use a notation, be careful with those two. You see this C. Oops. Maybe you use C1.
Oh yeah.
Use
C2. Yeah.
Okay. All right.
Thank you.
Thank you. Thank you. So I think Christian is next. Question 9. Then Suzanne, question 8. Then Yinping, 11.
Okay.
Les, David, 10. Then Sushan, 1. Okay.
Okay, attaching my file right now.
Oh, probably coming up. Not yet.
It's uploading.
Mm-hmm.
Okay. Converting. I didn't realize it was gonna like take time to like upload. Okay. Where is it? There it is. Okay. Now 9, which is right here. Okay, there we go.
Yeah.
So for question 9, it may look a little like out there, a little sloppy, but like I get to the answer. It was like a little bit of conceptualization because like the question was asking for like it was asking one question, but it was really asking two questions because first the question wanted you to make a function that's proportional to the rate of bacteria over time. So so what I did was that I used the idea of making a differential and then integrating it so I can get this exponential function of AE to the power of KT, K being the rate, T being the time. Once I did that, I had to remember that the question wanted you to find out, well, make a function in which that the population is over 24 hours, it is 10 times the original population. So to like understand it, I use a substitute. Like I use 8 as an example for a population, and with the 24 hours, I converted because I knew that T was going to be seen in years at least every time. Like I'm used to perceiving it in years, so I converted 24 hours to in terms of years. So it's still 24 hours, it's just in units of years. So what I did was I used this mock sort of equation right here, knowing that it's going to be 10 times, I put 10 times 8. And I kept in mind that 8 is the original population. So 8 is really like any variable, A, X, whatever. So I just wrote it down, simplified it, made it in terms of K, and then I have this final expression of ln 10, ln of 10 times 8 over 8 is equal to, over, which is over 3 over uh, 1095 is equal to K. With this question, I have an equation that tells me what's going to happen to a population, which is 8. How long is it going to take to double the rate at which it's going to double, which is K. And then if I go up here, like instead of using K, what I did was at the very top, well, sorry, not K, sorry, I mean A. Instead of using A, I use A, and then I simplified it, and then I got ln 10, right? And also, like, instead of using the decimal form of 0.0273 in terms of like that being 24 hours, I found that it was best to use the fractional rational number, because like if I used a decimal, it wouldn't be entirely accurate. It would give me like a number close to the population doubling instead of its exact number. So, and I have an example right here that shows P of T is equal to A, which is the final form that shows a population, being multiplied by 10 in the matter of 24 hours. If you put the fraction form of 24 hours into this T right here, you should get 50, which is shown by me plugging in 3 over 1095 and getting a population double from 5 to 50. Well, not double, sorry. That's the second part. This is multiplied by 10. Now, if I'm going, okay. Now that I'm going into the double part is this up here with the 2a is equal to a to the e of ln of 10 over that long decimal that it just means 24 hours. It's best to use the fraction. I learned the hard way. So that's the second page in which I solve the top up here. That's a different question. I solved for the time that it would take for the population to double, and which is the 2a, which was much cleaner on the first page. But this is just me like simplifying it and finding the time in terms of t that I will have the population double. And if you look past, like if you just look at the right side right here, you can see that as I was like plugging in my answer, which is ln of 2 over 1095 ln of 10 over 3, when I plugged it in, I got that my population doubled in a matter of 7.2 hours. Mind you, the 7.225 is not even that accurate because I used a decimal at the point, but the t with the fraction inside of it of 1095, right? That's more accurate, but it is like 7.2 hours. If you just think about it, 7.2 hours, it's doubling. It actually makes sense because in 24 hours, it's 10 times the amount, and it's an exponential function. So yeah, that's my answer.
All right. Okay. As a presentation, all right. Okay. All right. Thank you. Thank you. So that's Christian. All right. Anyone has any questions for Christian? Okay. Next one, Suzanne.
Here, Professor.
All right.
All right, 1 second.
Okay.
Just waiting for it to upload. Okay, so this is number 8. I'm supposed to find the differential equation of dy over dx equals 3x squared into y squared plus 1. So firstly, sorry, I separated the equation. I moved 3x squared over to this side, and then I solved for dx, also moved that to the other side. So then this side will be dy over y squared plus 1, and the other side will have 3x squared over times dx. So the same thing, I made this 1 over y squared plus 1 times dx, and the other side still remains the same. And then just find the integral of both sides. So in order to do that, we made the left side, find the arctan of that, and use the power rule on the other side, which was arctan y equals x cubed plus c. And then go back and plug in the y into 0 equals to 1 from the original equation. So then y here will be equals to 1, so it's back 1, and the x will be 0. So instead of x cubed, it would be 0 cubed plus c. And then so for that, we find the tangent of both sides, and that will be give you pi over 4 equals to c. And then we just plug it back into the original equation, which we got right here. So it will be arctan y, and it will be x cubed plus the pi over 4 that I got here. And that will solve that. That will give you y equals 10 into x cubed plus pi over 4. And
All right.
that's the answer for that.
All right. And my question is, can you, for mathematics, we always look for simplification. Is it possible to simplify this?
Okay. Okay. This one right here.
Yeah. Tangent x cubed plus pi over 4. Can simplify this, right?
Yeah, you can simplify.
Right. Okay. Thank you. So this is Suzanne. The next one, Yingping. Question 11. Then Liz 4, David 10. Shu Xian 1. And Moses 2. Okay.
Okay, can you okay, let me press. Can you see my screen?
Yes.
Okay, my question is, a turkey is heated in an oven to 200 Fahrenheit. At time t equals to 0, it's taken out of the oven and put on a counter in a room whose temperature is 70 Fahrenheit. After 20 minutes, the turkey's temperature is 150 Fahrenheit. At what time will the turkey's temperature be 125? Follow the Newton's law of cooling. We have the function d temperature over d time equals to k times a minus t. We based on the question, we have the constant temperature A is 70 Fahrenheit. So the d temperature over d time is equal to k times 70 minus temperature. We have the cross multiply. We get the d temperature minus over 70 minus temperature equals to k times d time. Integral both sides. We have the negative ln and the absolute of 70 minus temperature plus C1 equals to K times plus C2. Since the question is cooling down, so 70 minus temperature is less than 0. We have negative ln temperature minus 70 plus C1 equals to KT plus C2. And we got the final answer is T equals to e to the negative KT times C4 plus 70. And based on the question, we have T0 equal to 200. So we will get the C4 plus 70 equal to 200. C4 is equal to 130. So the formula of T is the equation of T is equal to 130 times e to the negative KT plus 70. And when T equals to 20 minutes, the temperature is equal to 150. So T20 is equal to 130 e to the negative 20k plus 70 equals to 150. We get the k is equal to ln a over 13 over negative 20. And we want to know at what time will the Turkish temperature be 125. So we have 130 e to the negative kt plus 70 equal to 125. And we got the final answer. T is equal to 35.4 minutes.
Okay. Thank you. So I want to see. Let's go back to. I think it's a Christian. In your question, right? Christian converted this. So this is a good example to tell a Christian, you don't have to convert into years. Okay, as long as in the question the time is consistent, there's no need to do any conversion. Just like this question. You know, if we stay with the minutes from beginning to end, we're talking about in minutes. That's fine. There's no conversion needed. You know, if in the question the time is not consistent, the time unit is not consistent, we need to conversion. All right, thank you. So this is Yingping. Also, if possible, everyone, presentation like this, you know, the writing is very neat because when you present, right, you want other people to easily understand you. You want to deliver your message as easy as possible. Okay. Let's see. Liz, question 4. Then David, 10. Then Sushan, 1. Moises, 2.
I'm gonna present question number 4. It has to find general solution. It's a pretty simple and easy question. So it's dy over dx minus 1 plus x factor 1 plus y equals to 0. So the first thing I did is that I rewrite it by letting the y over dx be on one side on its own. And after I rewrite it again so I can have all the y's in one side and the x's in one side. So it becomes dy over 1 plus y equals to 1 plus x times dx. So now I process to integrate both sides. And to do this integration, I use like u substitution. I made u equals to 1 plus y, and then du is equals to dy. Because, you know, the derivative of 1 is 0, and the derivative of y would be just 1 dy. So du is equals to dy. So that makes we have integration of 1 over u du equals to integration of 1 plus x dx. So when we integrate both sides, we end up with ln of absolute value of u equals to x plus x squared over 2 plus c1. And we replace back u by the value that we assigned before, which was 1 plus y. So it's become now ln of 1 plus y equals to x plus x squared over 2 plus c1. So to get rid of the absolute value, I rewrite it, replacing like c1 by c2. So it's become ln of 1 plus y equals to x plus x squared over 2 plus c2. And to get rid of the ln, I use the exponential. So it's ln of 1 plus y. When I put the exponential, it's cancel the ln. So we are left with 1 plus y equals to e exponent x plus x squared over 2 plus c2. And then I process to rewrite, and I replace e exponent c2 by c. So I have 1 plus y equals to c e exponent x plus x squared over 2. So now I solve for y. So by letting y be on one side on its own, so it's become y equals to c e exponent x squared over 2 plus x minus 1. So that will be the general solution for the differential equation.
Okay. Yes, Gregory, question?
I have a question. I got something a little bit different, but I want to know if it really matters.
What did you get?
So I got y equals e to the x squared over 2 plus x plus the constant, and that's all in the exponent of e, and then minus
Yeah.
1.
Minus
You see,
1. Yes, it's the same thing.
you see what listed here?
Yeah.
It said let c equal to e to the c2.
Oh, so it's just the constant. Okay,
Yeah, it's just a constant.
great. Thanks.
Yeah. You're welcome. All right. Okay, David's turn now. 10, question 10. The Moses, the Sushan one, Moses 4. No, Moses 2.
Okay, so in this problem, you are told that you have a bank account with $10,000 in it, and it increases annually by 4%. It compounds by 4% annually. And so I just used the formula for the continuously compounded rate, where A of t equals A naught times e to the RT. And the first part of the question, it wants to know how long it's going to take to double in amount. So basically how long it's going to take to go from $10,000 to $20,000. And so as you could see, I just cancel out the zeros, and it's a 2-to-1 ratio. And then I cancel out the A naught. And then what I do is I take the natural log of both sides and then divide to solve for t, which ends up being 17.325 years to double the amount of money. Part B is how much money will you have after 10 years? And so to do this, you can just plug in 10 into t and to the original formula. And what we get here after just plugging in is $14,918.25.
All right. Thank you. That's David's. Sushan, question 1. Then Moses, question 2. Then lastly, we'll have Ryan talk about 3.4. You're welcome. Sushan, are you there?
Yes, I'm here, but I don't know how I find the like share file, but I save in the desktop. I cannot find that.
Oh, okay. You try to find it. So
Let me
we're gonna.
put this way. No, this is not mine. Yeah, I cannot find it.
We'll come back to you. Okay, not
Okay,
to worry.
all right. Okay,
You try
thank
to
you.
find it. Yeah, we're
Yeah,
gonna go.
let me try to find it. Okay, thanks.
Okay, we're gonna go with. I think Moises question 2.
All right, it's uploading right now.
Okay.
Can you see it?
Yeah.
Okay. So first I just moved the y, 3y to the left side and then the dx to the right side to separate the variables and integrated both sides. And because of the right side, it's just a 1. There was not much work in there. It's just putting an x plus a constant labeled as C2. And on the left side, it's just a constant times 1 over that is just ln y plus another constant. And then after that, I moved the C1 from the left side to the right side and multiplied 3 on both sides to cancel out on the left side and leave the ln y by itself. And so I got 3x plus a third constant. And after that, I just solved for y by putting,
Oh, I think Sushan is trying hers.
oh,
Yeah.
I'll see if I can
Yeah,
bring him back.
share. Yes.
Yeah, okay.
Right.
So yeah, and then I just canceled the ln by putting e as the base, both sides. So now I have y equals to e to the power of 3x plus c, and separated the constant by doing e to the power of 3x times e to the power of a constant, and labeled that constant as a, and I have my answer as y equals to a, which is just a constant times e to the 3x.
Yeah, okay, great.
And that's about it.
Yeah. Okay, so Shuxian, let us know when you're ready, okay?
Oh,
Okay,
let me try. So
you want to try now? Yes. Yes, you succeed. But I cannot hear you. Are you talking? I see your work here.
yeah. Hello.
Yes.
You heard me? Oh, okay.
Yes.
Today I choose the question 1 is to find the general solution to the differential equations. The question is dy over dx equal like x square over y square. We know that I use like a separable equation like xy equal x square times 1 over y square is equal gx hy. So y squared dy equal x squared dx. I integrate like both sides, and then the left side y squared dy integral is y cubed over 3 plus c1 equal the left side is s cubed over 3 plus c2. So y I multiple like 3 both sides is y cubed plus 3c1 equal x cubed plus 3c2. I combine like a constant. So y q equal x cubed plus c3 is general solution. I think I didn't simplify, I suppose. And then the simplify is y equal like x cubed plus c3 is like 1 over 3.
Yeah, cubic root. So y
Right,
equals the cubic
right.
root of x
No,
cubed
because
plus.
I did this one is first. I didn't know. I saw your like example of
This is
y
fine too.
cubed.
This
Yeah.
is fine.
So
This is
all right.
fine.
Yeah.
Yeah.
I think when I heard a lot of percent, I know this is not simplified. So that's why.
Yeah, it could be
I
simplified.
yeah. Okay.
Okay, good. Succeed. You succeed. Great. All right, so now we go with Ryan. So Ryan will be, so before Ryan presenting, I'm gonna show, let me talk a little bit first. Then we go, because Ryan, So let's go to course document. Because Ryan chooses from day 3. And it's okay if you go ahead of the class. I just want to give everyone a heads up what he's going to talk about. So we have this form. So last class we talked about separable equations, right? So we can use the equal sign in the middle, and the left hand side could be all in terms of y, the right hand side all in terms of x. Then we can integrate both sides simultaneously. So we get a solution from there. But today we're going to talk about this. We're going to deal with something like this. It's a linear, right? Because it's a fourth order derivatives. But here we see it's not separable. We have a function of x multiplied by y. And then we have another function of x. So today we're going to dealing with an equation like this. All right. Now we go to Ryan. Ryan is going to show us how to solve such a problem. Ryan, your turn.
So this is question 4 from the next homework, and it basically just again asks us to solve the initial value problem. So we have this is differential equation with an initial value y of 1 equals 0. So as Professor Chen showed, the first thing that we want to do is we basically want to get that y prime on its own on the left side. We also want to get the y also on the left side. So we want basically this kind of structure. And I know it. I know the notes used p of x and q of x. I just prefer to be a little bit simpler and use a and b. And so we know that we can basically subtract 2y and move it to the other side, and we can also divide everything by x. And so our function becomes this. It's still technically the same function. We didn't do anything to it yet. Now we need something called an integrating factor. I'm sure Professor Chen will go into the intricacies of it a bit more. But basically what we want to do is we want to take this term right here, and we want to do e to the integral of that term minus the y. So basically we get e to the integral of -2 over x. Then solving that, we get e to the -2 ln x, which is just e to the ln of x to the -2, which is then just x to the -2. Then, by some algebraic wizardry, we can basically just do the derivative of our answer here times y, just regular y, it's always y, equals, again, our answer times b. So that's what was left on the right side. Doing that, you basically get x to the -2 times y equals x to the -2 times what we have left, which is x squared sine x. Of course, as you can see, these two cancel out, and so you're just left with sine x. Now, here we have a very simple differential equation. We just integrate both sides. Here we have a derivative on this side and an integral. They cancel out, and we're left without a c, because the c is essentially taken care of by both operations. Now, here the integral of sine x, that is, of course, negative cosine x, and there you have your constant term. You can then separate y out by, I guess, multiplying x squared on both sides, just to cancel that out. And so this is basically the general form. However, we need to make it so that y of 1 equals 0. So of course you plug in y of 1 and you plug in 1 for every x. What you're left with is 0 equals negative cosine of 1 plus c. Cosine of 1 is not a pleasant number. And so you get c equals cosine of 1. And you just plug that back in for c, and this is your final solution. And if you want, you can check that in a calculator, and both sides do in fact equal each other when you put in that function.
Very nice. Very nice. All
Thank
right. Ryan. So now, okay, as Ryan indicated, so today, this section is all about calculating something called integrating factor, just a name, right? Because in mathematics, anything important, we like to give a name. So in this case, if we encounter such equation, right? Again, you see this is P of x times y and Q of x, right? So we have a function of x, we have another function of x, but multiplied by y, then first order derivative. If we have such equation, so what do? Some smart people did this. So let's do something called integrating factor. So we call this rho of x. How is it defined? Is rho of x just a name. You could call anything, right? But by convention, we call this rho of x integrating factor. So how is this defined? Is e to the integration of p of x, okay? So e to the power of integrating p of x. So what do we do with this integrating factor? We want to multiply every term in this equation by the integrating factor, and something marvelous will show up. So we multiply every term, first derivative by that, p of x times y by that, and q of x by that. So every term, so three terms, and we want to multiply every term by such integrating factor. Okay. So integrate p of x. Which one is p of x? The one multiplied by y. The one multiplied by y. Because this one will change, right? So we multiply by that. Then we use these facts. So the fact of this is, if we take derivative of the integration of p of x, that's just p of x. Okay, this is p of x. So we have this term, and then we have this term. We have this term. So let's look at this. So now we have this, so we know this one equals to p of x. So the left-hand side, right? So the left-hand side, the two terms, the left-hand side is just this. So we have, this is the first term, this is the second term. And if we do this, those two, we see that just equals to this by this fact, right? Just take a look of this. Then the right-hand side, right? This is right-hand side. So we know these two terms equals to this term. So that's why we can equal this term with the right-hand side. And then what do we have? So we integrate this. So we get back this. Then we integrate the right-hand side So have this, well, of course, adding a constant term. So this is the E term. This is the E term hiding here. So we divide by both sides of this E term. So we get a Y equals to the E to the negative term. Negative X basically is just dividing by this term of this. The notation is complicated, but once we see the example, it becomes much easier. Yes, David?
Sorry, where does that constant come from again on the right side? Because you didn't take an integral yet?
No, we did. We integrate this. We integrate this. We get this term.
Oh, I see. Okay, and then you put it on the other side.
Yeah, we integrate this. We get this. Yeah, instead of a plus C1 on the left-hand side, plus C2 on the left-hand side, we could just plus C on one side.
Okay.
Okay. So the notation is quite complicated, but let's see an example. So we'll come back to this. We'll come back to, oh, let's see these steps first. So steps of solving such equation, okay? So first we calculate the integrating factor, all right? As Ryan did in his example, we're calculating this. So we define the integrating factor as e to the integration of the p of x. Then we multiply every term by the integrating factor. Then we use this fact, okay? Then integrate both sides, then solve for y. Let's see an example. So we see an example, then you can go back to these general notations. Let's see, we have this. Okay. We have 2xy prime plus y equals to 10 square root of x. And well, we only want to deal with real numbers. So we let x even be greater than 0, not even equal to 0, because we want to divide by x on both sides at a certain point. So that's in the form of this. So we could use the integrating method. So we divide by 2x, right? We divide by 2x. So we get a y prime itself, then plus y divided by 2x. Then with 10 square root of x divided by 2x now, we get a 5 divided by square root of x. So this is p of x. This is q of x. So the integrating factor is defined over p of x. So the e to the integration of p of x. So that means in this case, for this example, p of x is 1 over 2x. So we just do e to integration of 1 over 2x. Right? So integrating that, so half is a scalar. We pull half outside. And integrate 1 over x, that's just a linear ln x. Because x is greater than 0, we don't have to put the absolute sign for x. So this, simplify this, e to the half times ln x. This is e to the ln x raised by half. This is the square root of x. Right? So this is our integrating factor. Right? So that's the rho of x. So first step is to, for such equation, we calculate the integrating factor, which is defined as rho of x. We don't really need to use rho of x. It's just to, just e to the power of integrating p of x. Yes, David?
For the first step, you just divide everything by 2x, right?
You want to separate this,
Yeah.
because look at this form. This form has y prime plus this. Well, doesn't matter this on which side. You just have to have y prime by itself.
when you divide by 2x, what happens to 10 square root of x?
Well, 10 square root of x becomes 5 over square root of x, right?
But wouldn't
10
that
square root
be,
of x divided by 2x. 10
okay.
divided by 2 is
Oh,
5.
oh, okay, I see. Sorry.
Square root of x divided by x, that's 1 over square root of x.
Thank you.
You're welcome. So the integrating factor is square root of x in this case. So we just multiply every term by the integrating factor. Right. We just multiply y prime with the integrating factor, square root of x. We multiply this one with square root of x. We multiply this one with square root of x. So we get a new equation. And we can observe, we can staring at it, right? So if we take if we differentiate this, right? Just think, if we differentiate this, so what is that? We get this by product rule. We get this, right? So the miracle is this one. The miracle is once we multiply by the integrating factor, we just get a d of this dx, right? So this two is just this. So that's the miracle part. So that means derivative of this square root of x times y equals to 5. Okay. So that's the miracle part about multiplying, calculating the integrating factor, the multiply every term by the integrating factor, because we just get the left-hand side to be the derivative of square root of x y. Right? This is square root of x y prime plus this. So this is just a product rule, right? When we differentiate those two terms, this one term, by product rule we get this. So this is a miracle. Then we just have this that equals to 5. Right? We integrate both sides. Integrate this side, we get square root of x times y. Integrating 5, get 5x plus c. Then we solve for y by dividing square root of x on both sides. So we get a general solution as this, as such. Anyone has any question? Now let's.
Yeah,
Yes, David.
Oh, this is Gregory. I think David's hand
Oh,
was just
Gregory.
up.
I'm sorry?
No, I think David's hand was just still up from the last time.
Oh,
Yeah, I have a question though.
yes, please.
Could you derive the integrating factor for us, since it just kind of pops out there, you know?
It's defined. Oh, you mean derive right here?
Yes. Not the
Right.
answer, but like when you first introduced it as rho of x equals to e to the power of the integral of px. Yeah, that one.
That's just by definition. So we
Okay.
define this such integrating factor by this. Right?
Okay.
You don't really have to remember rho of x. That's just for theory, right? You have to remember this. E to the power integrating the p of x. Yeah. If you think about it, why we do that? Because once we do that, we multiply those two terms with that, we get, that's by product rule. Right. From the example, it's easier to see from the example.
Okay.
Which part? Here, this here. Right. Because the integrating factor will bring such a result. Well, we'll make these two terms on the left-hand side to be the differentiation of these two.
Okay. Thanks.
Yeah. Because of this, that's why we multiply by integrating factor.
Cool. Thank you.
You're welcome.
All
You're
right.
welcome. Yeah. So let's go through the steps again. So to deal with such equation, all right, remember P of x times y, that's Q of x, all right. So our focus on this P of x. And we want to put the equation exactly in this form. We want to put the equation exactly in this form. So y prime plus P of x, y, and then we leave Q of x on the right-hand side. We want to start the equation exactly in this form. Then we calculate e to the power of integrating P of x. Calculating this, because this is going to be our integration factor. Then we multiply by every term. We have 3 terms. We multiply 3 terms with such integrating factor. Then by this fact, then we integrate it. Once we have that, so we multiply everything by that. Then the left-hand side is the result of this. Then we integrate in both sides. Then we solve for y. Right. So go back to such example. We see we have a 2x y prime plus y equals to 10 square root of x. What do we want to do? We want to single out y prime, right? So that means we want to divide by 2x for 3 terms. When we divide by 2x for 3 terms, we result with y prime. Now we have single out y prime plus 1 over 2xy. So 1 over 2x will be our p of x. So we have dy dx plus p of xy on the left-hand side. We have q of x on the right-hand side. Now the equation is in the right form. We calculate so we have p of x now, which is 1 over 2x. We calculate our integrating factor, which is e to the power integrating p of x as a power. So this is integrating 1 over 2x. Well, we can pull half scalar out. So integrating 1 over x, just ln x. Because x is greater than 0, we don't have to put an absolute sign for x. Simplify this, e to the half of ln x, that's just e to the ln x is x. So that's just square root of x. So for this example, the integrating factor is the square root of x by this calculation. Now, next step, we want to multiply integrating factor with these 3 terms. So once we multiply integrating factor with 3 terms, we get the square root of x y prime plus this term equals to 5. The miracle is the left-hand side is just differentiation of square root of x and y. Implicit differentiation. We differentiate square root of x, we get this term. Differentiate y, multiply by square root of x, we get this term, right? So implicit differentiation, we integrate x term and y term simultaneously. That's this. So the left-hand side, just this. So that's the miracle part. Then that equals to 5, right? So yes, Su Xian. Su Xian, are you talking? I cannot hear you.
Oh, okay. Okay, you highlight for that. Oh, okay. You heard me now?
Yes.
I have question. You says you need to multiply by x square root over here. No, over here. So I mean your mean is like for the left hand side, suppose only the constant or something like that.
Okay, so we have calculated integrating factor as the square root of x. So
Yeah, I
now
got this point, but I didn't get why you need to multiply like by x square root over here. X squared both sides.
That's the trick. Because once we multiply square root of x, the integrating factor, the left-hand side just becomes this.
I got this point too, but my question is for the like left hand side. You said 5 only the constant left over here, the left or something.
Okay, so
without like x and y, right?
So what's your question?
No, for the left hand side, this equation, suppose and then the constant or something without x and y. All the x and y go to the left hand side, so right hand side only the constant.
Okay, when you multiply this term by square root of x, what do you get?
5.
Yeah.
Yeah.
Yeah, okay. So I'm sorry, I don't get your question.
No, the question is, okay, for the right hand side, all the x and y supposed to move back to the right hand side. Oh, no, right hand side supposed to move back to the left hand side, the equation. X and y.
You mean from the beginning, right? We have to put it in this form. Is that your question?
Okay. All right.
So that's from the very beginning. We have to put, so whatever the equation we're given, we need to put it in this form.
Okay.
Okay, we need to put it in this form. Then we calculate, then we identify P of X. So this 1 over 2x is our P of X. Then here, this 5, just by calculation, when we multiply integrating factor on both sides, the left-hand side becomes such, the right-hand side becomes only 5. And the miracle is the left-hand side. The left-hand side is just the differentiation, implicit differentiation of those two, square root of x and y. Well, of course, this one equals to 5, so we can equal this one with 5. Then we integrate the step. The step, we integrate both sides. We integrate this side. Integration and differentiation cancel out. So we just get square root of x and y times y. Integrating 5, we get 5x plus a constant. Then we want to solve for y, so we divide by square root of x on both sides. So in the end, we have our general solution as such. Basically 3 steps. First step, put in the right form so we can identify P of x and Q of x. First step. Put in the right form. Then once we identify our P of x, we want to calculate integrating factor. Is e to the power integrating P of x. We calculate that. Then we multiply every term, well, 3 terms. We multiply 3 terms with the calculated integrating factor. Then after calculating the integrating factor, the left-hand side will becomes derivative of, in this case, derivative of let's use this form. Right, that's why we want to use rho of x. We want to use rho of x for this integrating factor. That just becomes a derivative of rho of x, the integrating factor, times y. Let's see more example to make sense. Yes, Gregory, question?
More like an observation. So
yeah.
I think I'm not really sure how they came up with it, but it was a really good idea to do the integration factor, since you get your answer in terms of y and y only, right?
Yeah, it's
Like
a genius idea.
yeah, it's very, very good idea. I was a bit confused as to like why you were doing it, but I see why, because you only end up with terms of y at the end.
Right.
Yeah,
So
that's it.
okay, all right, thank you.
Mm-hmm.
Because the notation could be troublesome, but let's see more examples. So that's the first example. Let's see this example. So this one with the initial value, so we'll be able to get one specific solution. So this one is defined as y prime equals to 2xy plus 3x squared e to the x squared. All right. So remember that, let's start with this in our head. All right. Always. So we have y prime plus p of xy times y equals to q of x. So we want to put it in this form. So we want to move 2xy to the left-hand side. So we get a y prime minus 2xy equals to this. So what is our p of x? It's a negative 2x here. So y prime minus 2xy equals to 3x squared e to the x squared. This term has no y, so this is q of x. This is our q of x. And so p of x is negative 2x. Right? So we put it in the right form so we can identify p of x. Then we calculate our integrating factor, which is just e to the integrating negative 2x. Or negative 2x integration is negative x squared. So our integrating factor is just e to the negative x squared for this question, for this one. Anyone has any question for how to calculate the integrating factor? Put it in the right form. First step, identify p of x, calculating e to the power. So you could do, what you could do is, you could integrate p of x. So once you identify p of x, integrate p of x, then your integration factor is just e to the power of the integrating of p of x. So in this case, it's just e to the negative x squared. Then multiply the three terms. Multiply these two terms by the integration factor. Multiply this term by the integrating factor. So get this. So the left-hand side is this. The right-hand side is this. And the right-hand side can be simplified to be 3x squared. And the left-hand side, we know just derivative of the integrating factor times y. And that equals to the right-hand side, 3x squared. You see, we don't have to do anything with this. We just notice, we just take it for granted. We know this is the derivative of the integrating factor times y. Then the right-hand side, q of x times the integrating factor, in this case, just 3x squared. Then we integrate both sides. Integration and the differentiation cancel out. So we're left with e to the negative x squared times y. Then integrating 3x squared, this is x cubed. Well, we just add one constant. We don't need to add c1 on the left-hand side, add c2 on the right-hand side. We just add c on one side. Solve for y, so we multiply e to the x squared on both sides. So we get y equals to e to the x squared times x cubed plus c. General solution. Well, we're given initial condition. When x is 0, the y value is 5. So just plug in. X is 0, this term is 1. X is 0, this term is 0. This is y equals c, c equals 5. Right? C equals 5. So we just plug in for c. So a particular solution is this. Anyone has any question? So you could think as 4 steps, right? First step, first step, put it in the right form. Put it in the right form. Y prime plus P of X times Y equals Q of X. Right? Because we can, in this case, we can identify P of X. Once we identify P of X, we integrate P of X. So the integrating factor will be e to the power of the integrating of P of X. Then we multiply every term by the integrating factor. Then the left-hand side becomes the derivative of integrating factor multiplied by 1. Right. Then usually the right-hand side Q of X times the integrating factor, still a function of X. Then we integrate in both sides. So we basically identify, right? So we just take this step as granted, you know, we take it for granted. Because it's just a fact, it's a fact. Then we integrate in both sides. Then we solve for y. Any questions for this example? Let's see more examples. Let's see this one. Y prime equals this. And then we see this just function of x. And this is function of x times y. Right? We want to move this one to the left-hand side. Because we want the y prime and then the one with x with y. P of x times y. We're given initial value. And we restrict the x value, goes from negative pi over 2 to pi over 2, without those boundary points. So first we put in the right form. Y prime plus P of x times y equals to Q of x. Put in the right form. Now this is our P of x. Let's integrate P of x. So integrate P of x. We gotta use U substitution, right? So integration of tangent, we want to change it to be sine over cosine. Then we let U be cosine. So du is negative sine, right? Negative sine. So negative du, so sine x dx appears in this sine x dx. So that's just negative. So this whole thing, so that's just negative du. So we'll have 1 over u, negative du. We substitute back in. We just get the negative, integrating du over u. That's just ln u. Or this e to the ln u, just, well, e to the ln u, just u. U raised by negative 1, that's just 1 over u. And what's u? U is cosine x. This is 1 over cosine. 1 over cosine is just secant. So as you can see, a lot of work is to calculating the integrating factor, right? We put in the right form, identify P of x, integrating P of x, then that becomes power of e, or e to the power of integrating of P of x. That's the integrating factor. So in this case, our integrating factor is secant x. So multiply secant x on both sides of this. Then The left-hand side has become differentiation of the product of integrating factor with y times y. That's the miracle part. Integrating factor is a secant x. So this left-hand side just becomes differentiation of secant x times y. On the right-hand side can be simplified to be cosine x sine x. But if you want to rewrite that, that's just half of sine of 2x. Then we're integrating both sides. So the left-hand side becomes integrating factor times y. The right-hand side, we have to do a little bit of calculation. If you want to change, right, cosine x sine x, you could define u, then with du, calculating du. Or it's just half of sine of 2x. You can go from there in any case. In the end, you get negative cosine square x over 2 plus c plus a constant. So solve for y, so we divide by the integrating factor on both sides. So our general solution is this. With the initial condition, we substitute in 0 for x, 3 for y. So solve for c. C equals to 3.5, which is 7 over 2. So we get a specific solution with the initial condition. Anyone has any question? All right, I think we have one more example. Oh no, that's it. Now let's go back to the steps. Oh, now let's go back to the even before the steps. Now maybe easier to understand this. So we define rho of x as e to the power integrating p of x. Then we multiply, we put it, well, we started with the right form. We started with right form. Then we multiply the integrating factor with these three terms. Then the left-hand side, just integrating the rho of x times y, right? So this integrating factor is just our rho of x. It just becomes, so this, by multiplying the integrating factor, the left-hand side is just the differentiation of the integrating factor times y. So that's exactly why we want to multiply by the integrating factor, because of such fact. Then we just get this. Then we just get this, right? We integrate both sides. Integration, differentiation, cancel out. We just get y times the rho of x, the integrating factor. Integrating the right-hand side. Then we see just y equals to this right-hand side divided by rho of x, which is the integrating factor. Now go to the steps. Put in the right form, calculating integration factor, integrating factor, multiply integrating factor, then by the fact of such, integrating both sides, then solve for y by dividing the integrating factor on both sides. Anyone has any question? That's it. The notation, right? Sometimes, when the dry mathematic notes doesn't make sense, you go to the example first. right? Because the example is concrete. It's easier to grasp. And then you go back to the dry notation. If you have no question, you can go ahead to start doing your homework. I think that's the best way. Once you get out from classroom, you do your homework right away because you have a fresh understanding of the examples. If you do have questions, I'm here. If you do not have questions, you're free bird for tonight. And don't be totally free starting to do your homework. If you have any questions, I'm here to answer your question. Yes, David.
Hi, this is like an unrelated question, but you mentioned how each time we presented it added another 10% to the presentation grade. And you mentioned also that you could go over 100%. But I was wondering, would going over that 100% spill over into like the other grade categories? Or would it just
No,
count as 100?
It's only for this category.
Ah, I see. Okay.
Oh.
That's fine. Thank you. Have a good night.
You too. You too. Any other questions?
Yes, I have a question, Professor Chen.
Yes, Christian.
If two classmates have like the intention of, let's say there's no available questions to present on, is it optional for them to both present on the same question with their individual notes?
Okay, so let's see. Christian, hopefully next time your handwriting is better. Okay, you make a neat presentation. Sometimes
Yeah, I have better options. It's just that.
Right. So sometimes, okay. So under circumstances, so the second one can present. So if the first presentation is not as ideal, or the second presenter does not agree with the answer of the first one, so he or she may present the same question.
Okay, gotcha.
Okay. All right.
Mhm.
Yes, Shushin.
Oh, so sorry. So I have the question for the homework because when she present and then for the class 2 for the dy dx and then the minus 2e like a power s plus 2y, I don't understand why she used like substitute for this question. I didn't raise a hand before because I
Oh, you mean
focused. No,
you
not
mean dy?
yeah. For the last class and question 6. No, not for this class and for the PAX, the homework.
Okay, so okay, can you repeat your question again?
Oh, okay. Let him finish.
Okay.
Are you asking me the question or the professor?
Shuxian, we cannot hear you.
Oh, my question regarding the homework for the PAX class, the homework number 6.
Yeah, can you repeat your question?
I saw, and then he used like you substitute that method to solve this problem, but I didn't use that. That's good.
Yeah, you could have different approaches, but I don't exactly recall
Oh,
the
okay.
question itself.
Okay. Would you like me to share the question? I would like to see how you did it too then.
Oh, if you can share now, that's fine
Yeah.
because I try to understand.
Okay, no problem. I'll share the question
Oh,
right now,
really,
okay?
really appreciate.
Oh, no, yeah, of course, of course. Give me 1 second. I will pull it up now.
Sure.
Okay, thanks. Okay, I'll share my screen. Okay, here, right?
Oh,
This
yeah.
question 6.
Yeah, 6. Yeah.
Uh-huh.
Yeah.
So what did you do? I would like to know how
I
you did
did
it.
like a dy dx, and then I moved the 2e power x over 2y to the right hand side.
Mm-hmm. Mm-hmm.
And then I integral like both sides because, and then the right side.
Are you sharing screen?
Oh, I don't.
Because mine cut off. I'm not sure what happened. But if you would like, you could share your screen and like write on it.
You know, I'm very poor for the computer.
Oh, okay. Professor, could you probably like draw on the whiteboard for us so we could see?
Shuxian, do you know how to use this whiteboard?
No.
Okay. I guess Gregory, you can pull up your work.
Okay, sure.
I think I understand what she's doing.
Okay.
Yeah.
Yeah, I wasn't sure why the share screen stopped. I thought she was sharing. Okay, I'm following.
Yeah. If you
Oh, yeah.
if you pull this 2e to the x plus 2y to the other side, it won't be right because this is a separable. We want to separate the y's and the x. We want to put the x on one side, the y on another side.
Another side, yeah, correct.
Right.
I did the same thing up to like a dy e like a power 2y equal to e x dx. The same thing, but maybe the bottom one you use the like a U substitution.
Oh,
yeah, this
okay.
one I did the writing. Yeah.
Uh-huh.
Over here, yeah.
Mm-hmm.
No, I just in here, I just and then do like because when you integrate 1 over like a e power 2y, I just do like a ln e 2y. That's it. I didn't use the U substitute. But when
okay.
Oh, no. Hold on. Okay, now I understand her question.
Right. Maybe I did wrong because
Did I do it
don't
wrong?
know.
I'm confused now.
I have no idea, Professor. So.
Okay, I think I know what you're talking about.
Yeah.
Okay.
I just want to make sure everything is good for me because.
Yeah. Professor, did I do this okay? Is this legal to do?
Let's check.
Okay.
You went a long way.
Oh, I did?
Think about this.
Yeah.
Excuse me. You use U substitution, right?
Yeah.
So you let U equal to negative 2y. I'm sorry.
It's okay. Oh, I think I understand. ln of e to the 2y would just be the integral of this, right?
No. Shit. Shuxian, that's not right.
I'm not right? Okay.
No. Yeah. So
take your time, Professor, please.
That's it. Because this is the e term. This is e term. Okay, so let u be negative 2y. So what is the du?
Du is negative 2y squared. No.
So if you did you ask for dy or du?
Du.
Oh, okay. Du would be negative 2.
Right, would be negative 2 dy. Right. So in this case, you don't have negative 2 in this. So all you need is we want to substitute this one into u. But we only have dy here. What are we missing? We're only missing negative 2. So we divide by negative 2 on both sides. We divide by negative 2 on both sides. So dy is, so we just have to offset with negative half. Then we can change this one to be du, this one to be u. So this is just a negative half of u du. So how to integrate this? That's just a negative half. How do we integrate this, Gregory?
U power over 2.
Then?
Over 2.
Right. That's it. Just a negative u squared divided by 4 plus c. Well, what's u? U is just negative 2y. So in the end, it's just going to negative y to the fourth power. No, y squared, I mean. Right? Because this is a negative, u is negative 2y. Negative 2y squared. Negative 2 squared is just 4. 4 over 4 becomes 1. So it's just negative y squared. Gregory, did you get a negative y squared in the end? Or plus a term?
No. I'm still looking at it. No, I didn't.
I remember you did have a negative half times half. You did have a negative square.
I didn't solve for the y until like the very very end.
Okay, so that's it. It should be very simple.
Okay.
Negative y plus c. Shuxian, do you have comments?
Yeah. Oh,
that's
no,
what
that's
you
it.
have, right?
Yeah.
Okay, negative y
Okay.
squared plus c. There's no ln
Okay.
involved. ln is
Okay.
only for 1 over non-e term. So this cannot be e term. The bottom could be anything else. 2 plus y, y squared. So 2 plus y, 3y minus 1, something like that.
Okay.
Well,
Okay.
or like this. If we integrate some number over, let's say by plus c, that would be ln. In this form.
Okay.
When you integrate this
All right.
form, it will be ln.
Okay. I got
All right.
it. Okay.
Great.
No, you just said so use substitutes. I can use that
Yeah.
like that method to do it. So I did wrong.
Yeah. You
because
substitute.
and then yeah, because and then the I didn't take the class and then the like a whole pandemic. I took like a 4 and 3 years and then the vacation so long. So I just back to school last semester. So I need to start really hard. Okay, thank you, Professor.
You're welcome. You're welcome.
Good night.
Gregory.
Bye.
Good night.
Yes,
Gregory,
Professor.
do you have any question?
No, I think I'm all good. Let me just check the notes from today. I think I'll be okay.
Okay. All right.
All right.
All right. Liz, you have any question?
I'm not sure if Liz is here, but
She's here. I saw her. She's here.
Oh, okay.
Probably she has some. Yeah.
Okay, well, I'll wait until she's finished with her question.
Oh. No, she's
Can
gone.
you hear me, Professor?
Oh, she's reading. Oh, yes, Liz. Yes.
Yeah, I was saying I was okay. I was just following this exercise.
Okay. Do you have any question? No.
No, I'm good. Thank you.
Okay, you're welcome. Okay, go ahead, guys. Start your homework.
Thank you, Professor.
Okay, see you Thursday.
Good night.
You're welcome.
Have a good night.
Good
See
night.
you Thursday.
Yeah.
All right.
Good night. See you Thursday.
Bye-bye.
Bye.